Hey guys, so Kian here, and this is going to be a video about Shenmue animation, and we're going to see how far I can get through this video before I curse, because this is a bitch. So, we have the animation is combined, or the animations in Shenmue are all just bundled into one huge file, and of that one huge file, I've separated out the walk animation into its own individual file, and I've created an Excel file for it because it makes it a lot easier to break up the different groups and color assign them and make notes about it. So the general format of the file is there is a header at the top, and then it's split into 5 different blocks. We have block 1, block 2, block 3, block 4, and block 5. So going back to the header, block 1 starts immediately after the header. Block 2 starts at 0x36. So since I have 4-byte boundaries on this file, I had to use a little pipe to split the two of them. 0x75, which makes block 3 start about here. 0135 comes down here, and then the last one, block 5, is at 0xa0, which is here. And then this first value on the front here is a flag that tells you how large blocks 2 and blocks 3 are. So if it has a certain value, then block 2 will be 2-byte values, otherwise it'll be block 1 value or 1-byte values. And in this case, this will be a 1-byte value. For block 3, it'll be similar story for block B. 3, it'll either be a 2-byte value or a 1-byte value, and in this case, it is a 1-byte value. So of the blocks I'm most interested are blocks 5 and blocks 1. For block 1, the format of each entry should be something like this. The bottom 3 bits don't do anything. The next 3 bits after that are the rotation XYZ, and it could be backwards. I think it might actually be ZXY for the byte order, but in any case, these are the 3 rotation axes for bit flags for that, and then we've got the 3 rotation bit flags for position X, Y, and 0. And then X, Y, and Z, or Z, as you say in your weird European countries, but X, Y, and Z. And then from bits 9 and up are the bone ID. So if you just shift this down and ignore all these bytes, then all these bits, and then you get the bone ID, and that's what it is. And this should just kind of go up in order of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or whatever. They generally seems to be in order. So the confusing part about this is I don't know exactly what blocks 2, 3, and 4 do. They seem to have some stuff to do with the weight. That could be correct. It could be some kind of index. It could be some kind of table. There are a lot of different things it could be, and I don't really know specifically what it is. So I'm not going to make too much. I'm going to postulate too much into what these actually do. I'm mostly interested in the transformation values here. So there's 2 bytes on the front, which don't actually do anything, and then we have 2 bytes, 2 bytes, 2 bytes, 2 bytes. So everything is a half float for the different values. And as you can see, there's a little stuff at the top here, but if we just scroll down, most of the file, 80%, 90% of the file is going to be all these transformation values. So if we can decode the transformation values, then we should be able to decode the animation. And basically what animations are, assuming this is a normal animation, basically you have a list of bones, and then you have a list of frames. And for each frame, you're going to have a list of transformations for each bone. So you're going to have a transformation XYZ, and you're going to have a rotation XYZ. In most cases, for what I experienced in PSO, is the root bone only had position, so the root bone would be positioned to describe where the character is, and then everything above that, bones 1 through the rest of the bones, will only be transformation, or will only be rotation. And if you think about it, when you walk, you rotate your knees, you rotate your thighs, you rotate your hips, you rotate your elbows. There's really no time where your body really translates stuff, because that's like you got in a car accident. If you translated your ankle has moved over a foot and it's sitting beside you. That's where you have translation. Otherwise, most of the time, your body's just doing rotation. So your root position is going to be changed with position. All of the bones in your body are going to only change with rotation. And so that's generally how animations are encoded for a lot of times, is you have root position, and then everything above root should only be rotation in theory, unless you're doing something like inverse kinematics. And we'll see if Shenmue actually does that, or if it's just a weight system, or whatever. Because like I said, it's a bitch. But we're going to go ahead and switch over to testing in game, and I'm going to do a quick hypothesis as to so far what I've observed with how the game mix. So we're over in the game, and we're using... Oh, oops. Let's undo everything. Let's load back again. So we're in the game and we're using RetroArch, and this is because RetroArch gives you the option to create save states or decompress. And the nice part about this is because a lot of different emulators use a lot of different compression methods, and it's hard to figure out which gzip or gtar or whichever algorithm they're using, and you have to like read through the code, and often the code isn't that easy to read through, and then you still have to decompress and recompress and stuff like that. It's not fun. But RetroArch gives you the option to do uncompressed save states, and what that does is lets you see the system memory, the frame buffer. It just saves everything the system needs to run at that point and spits them out. So if we open up our editor over here, our console over here, what we can do is we can do a quick search, and what we do is we just read the walk file on its own, and then we pull up our save state, and then we look for the index of what we're searching for, and then we can get an index in the file position, and then we can split out whatever offsets we need. So in this case, the offset that we want is located over yay much in memory. And so we can go over here to our save state file, and we can go ahead and edit it. So this is where the walk animation, where the transformation values of the walk animation start. And we can go through and we can start just kind of messing around with it. So what I want to do is E333, this should be the 2 bytes for the X value, and then 743C, this should be the Y value, if I am correct. So we can go back here, we can load the animation, and Shenmue should disappear into the ground every certain frame. Now what's going on with Shenmue in this case is a lot of times there's kind of two different thoughts of where the root bone should be. One, the version I like is you have a root bone at 0, 0, 0, and then you have a bone number 1 is the hips, and the model is always relative to the ground. The other version is where you just have the root bone at the hips, and what happens is they have to translate use animation to translate where the hips are at any given moment. I think there's some, I don't know which one is better. I prefer the one that's at 0, 0, 0. But so the game is going to use the Y animation to preserve the Y position of Ryo's hips at any given frame in an animation. So this will always have a positive Y value in most cases, unless he's sinking into the ground. So if we set it to 0, Ryo will sink into the ground for 1 frame and then kind of spring back up again. So we can generally tell that this should be the Y value of the 0, or the Y value of the root bone animation. So if we do that's Y, we can say this one is Z, this one is X again, and so this one will probably be Z or Y again, because we've just looped over to the next frame. So let's go ahead and load this. Boom, and if we walk forward, we get at a slightly different point in the animation, Ryo sinks into the ground again. So we can go back, undo, and then do it again. So this is Y, 1, 2, this is Z, 1, 2, and this is X, 1, 2, and this should be Y again, 1, 2. So if we see, it starts with 3C, and this is a pattern that just kind of keeps going. So let's set these to 0. Let's go back, let's load the animation, and boom, he sinks back into the ground again. So we can see that this is probably where the root Y position is. And I went through and found it, and you can see 3C, 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 3C. It goes up to about here. And so this is all the root Y bone position. Now what's kind of messed up about this is if we look back at the thing here, if we go through it, block 1, and if we expect this is position XYZ, rotation XYZ, for all the bytes for rotation, position XYZ and rotation XYZ are actually set for all these values. So what I would normally expect to see in this case is bone 0 XYZ bone 1, or bone 0 position XYZ, bone 0 rotation XYZ, bone 1 position XYZ, bone 1 rotation XYZ, up and up and up, and just loop that for each frame. What we have is position XYZ for root bone, just kind of looped over and over and over and over again. So we need to find out. So we need to find out two things for this. It's one, we need to find out how many frames there are, and then two, we need to find out how many bones there are. And so that's kind of, we can kind of see how the transformation frames are grouped, and we can kind of see how they're put together. And so we just kind of need to go through and look a little bit more to see if we can try to figure out, just to make any sense for what frame and what bone we need to we need to apply the right values to. And yeah, and the problem is there's just like blocks 2, 3, and 4 just don't give a lot of hints for how they're actually doing that. Do they go here, look up something, look up what the bone should be, look up what the frame should be, and then kind of jump some position in the transformation table, or it's just a transformation table stacked end on end, and it just kind of does that. So that's kind of where I'm at. We can generally make a assumption that this is about where the root bone 0 position should be, and then we just kind of need to kind of go from there and just kind of do more testing. So that's my video for now, and just hopefully anyone who's working on this or anyone who's interested at all, hopefully this gives you a little bit of an introduction, even though if my understanding isn't that complete at the moment. So thanks for watching, and see you next time.